On your IP page, where you're going to be taking your notes today, title it Wave Properties. The essential question today is, what are the properties of different types of waves? Well, before we can even talk about different types of waves, we have to talk about what a wave actually is. A wave is a disturbance that transfers energy. Disturbance meaning some kind of vibration that gets caused or a wiggle that happens that will transfer energy from one place to another. Now, with talking about waves, we have a lot of vocabulary words that you need to know about the different properties of waves and how we describe them. Well, first, if we know that a wave goes up and down, then we have different terms for the top of a wave, that's called the crest, and the bottom of a wave, which is called a trough. Top of the wave is called a crest, bottom of the wave is called a trough. Now, as a wave moves up and down from its original place, we call that original place the resting line. The point right here and here and here and here, where the wave crosses the resting line, is called a node. A node is the point at which a wave crosses the resting line. The height of a wavelength always matters. The height of a wavelength, or the distance from the resting line to the top of the crest, or it could be from the resting line to the bottom of the trough, is called the amplitude. The amplitude is the distance from the crest to the resting line, or it could be from the resting line to the trough. Crest to the resting line or trough to the resting line. The wavelength is the distance from crest to crest or trough to trough. So it's basically from here to here or here to here on any given wave. We already talked about the frequency, and the frequency is how many cycles it has per second. So if we imagine a wave going up, down, and up, down, and up, down, and up, the amount of cycles up, down, up that it takes in 1 second is the frequency. So if we measure this in 1 second and the wave went up, down, up, down, up, down, up in 1 second, we would say that this has a frequency of 3 hertz. Now, there are 2 different types of waves that you need to know about. The first type of wave is called a transverse wave. In a transverse wave, like you saw in the video previously, the wave moves at a right angle or perpendicular to the direction of the wave. So imagine that you have a rope and you're holding it on one side. If your hand goes up and down, but the wave travels forward, then this would be a transverse wave because you're moving your hand up and down, but the wave is traveling forward. These 2 motions are perpendicular to each other. The second type of wave is a longitudinal wave, or also known as a compression wave. A compression wave is when the wave actually moves in the same direction, longitudinally, to the spring. Like, you can imagine this being like a slinky. If you were to push on one side of the slinky, then you're pushing in the same direction that the wave actually travels through the slinky. The push is in the same direction as the wave. So, now that we've gone through lots of terms and 2 different types of waves, your job now is to answer the essential question. What are the properties of the different types of waves? You need at least a 3-sentence summary to answer this essential question and at least 3 questions on the side of your Cornell style notes.